Assalamu alaikum. Welcome to lecture number 11 of the course on statistics and probability. You will recall that in the last lecture we began the discussion of a very important concept in statistics, and that is the concept of dispersion. I discussed with you the difference between an absolute measure of dispersion, which measures the dispersion in the same units as the units in which the raw data has been expressed, and also I discussed with you the concept of relative measures of dispersion. When we divide an absolute measure of dispersion by the corresponding average, we obtain what is called a relative measure of dispersion, and the most important property of this kind of a measure is that it is a pure number, and therefore using relative measures of dispersion we are able to compare the variability of two or more data sets. We discussed the range, the coefficient of dispersion, the quartile deviation, which is also called the semi-interquartile range, and also the coefficient of quartile deviation. और उसके बाद आपको याद होगा कि हमने मीन डिविएशन की डिस्कशन का आगाज किया था. Today we will continue with the discussion of the mean deviation, and I will discuss with you in detail the first case when we deal with the raw data, and then the case of the frequency distribution of a continuous variable. Students, आपको याद होगा कि मीन डिविएशन के हवाले से लास्ट लेक्चर के एंड में मैंने आपसे ये कहा था कि जबकि क्वार्टाइल डिविएशन और रेंज डिस्पर्जन को मेजर करते हैं अराउंड द मीडियन इन केस ऑफ द क्वार्टाइल डिविएशन एंड द मिड रेंज इन केस ऑफ द रेंज, मीन डिविएशन वो मेजर है जिसमें हमारी अटेम्प्ट ये होती है कि हम अरिथमेटिक मीन के अराउंड डिस्पर्जन को मेजर करें. Let me explain this to you with the help of an example. Suppose that we have data regarding the number of fatalities in motorway accidents in one particular week in one particular city, and the values are number of deaths on Sunday due to motorway accidents 4, and for Monday the number is 6, and then 2, 0, 3, 5, and 8. Adding these numbers, the total number of deaths for the week comes out to be 28, and dividing this number by 7, the mean number of deaths for the week comes out to be 4 deaths per day. आप जानते हैं कि इस वक्त हमारा फोकस एवरेज वैल्यू नहीं बल्कि जो वेरिएबिलिटी पाई जाती है इस फिनोमिनन में, दैट इज द नंबर ऑफ डेथ्स, द वेरिएशन इन द नंबर ऑफ डेथ्स फ्रॉम डे टू डे. This is the focus at this time. So, in order to measure the distance of any individual x value from the mean, students, we will simply compute all these distances as you now see on the screen. In the third column of the table that you see, the distances of the x values from the arithmetic mean, which is 4, come out to be 0, +2, -2, -4, -1, +1 and +4. Students, आपने नोट किया होगा कि some of these deviations are positive and some of the deviations are negative. Well, that is obvious. अगर हमारी x वैल्यू x बार से बड़ी होगी तो जाहिर है कि x minus x bar will come out to be positive. And if our x value is less than the mean, then the deviation will naturally come out to be negative. लेकिन अब सवाल ये पैदा होता है कि क्या ये deviations इस हालत में हमें कोई फायदा दे रही हैं in order to compute the spread of the x values around the mean? You will note that this is not the case. If I add all these deviations with each other, students, the sum comes out to be 0, as you just saw on the screen. और इसका मतलब ये हुआ कि हम ये कह रहे हैं कि overall dispersion of the x values from the mean is 0. But obviously, this is not very correct. Obviously, there is a variability in all these values around the mean. So there is something wrong, and we have to think of some way of overcoming this problem. The easiest way of overcoming this problem is to take the absolute values of all these deviations. So, as you now see on the screen, the absolute values of the deviations are 0, 2, 2, 4, 1, 1, and 4. Adding these absolute deviations, we get 14, and in this way, we have achieved a non-zero sum in our third column. Dividing this sum of 14 by the number of days in the week, that is 7, our mean deviation comes out to be 14 over 7, and that is 2. अब students, इसमें दो बातें नोट करने की हैं. एक तो ये है कि ये हमने जो एवरेज लिया है, this is the mean value of the absolute deviations, as I just explained. So, इस हवाले से इस measure का जो complete name है, that is mean absolute deviation. लेकिन short करने के लिए we just say mean deviation. दूसरा पॉइंट ये है कि ये जो हमने एब्सोल्यूट वैल्यूज ली हैं, उसमें अगर आप ज्योमेट्रिकली देखें तो देयर इज नो प्रॉब्लम, इसलिए कि एनी वन ऑफ दीज एब्सोल्यूट वैल्यूज गिव्स अस द डिस्टेंस, द हॉरिजॉन्टल डिस्टेंस between the mean value and any one individual value. May that individual value be to the right of the mean, may it be to the left of the mean. तो इन distances में से कोई distance छोटा है, कोई distance बड़ा है, और हम in order to get an overall idea, we find the average of these distances. जाहिर है कि छोटे और बड़े distances की जो average value होगी, that will be an intermediate value, and that intermediate value of the distance acts as the measure of dispersion of the values around the mean. So, the formula for the mean deviation is simple. It is the sum of the absolute deviations divided by the number of deviations. ये तो हुआ the case when we are dealing with raw data, as in the example that we just discussed. Now, what will be the formula in the case of group data, the case when we have a frequency distribution? As you now see on the screen, the formula in the case of grouped data is sigma f into modulus of d divided by n. अब इस फॉर्मूले की एप्लीकेशन के लिए 2-3 बेसिक स्टेप्स हैं जिनको आप जहन में रखिए. The first step is to compute the midpoint of every class, and that will be denoted by x. The second step is to compute the arithmetic mean of the data set using exactly the same formula that we discussed in an earlier lecture, and that is sigma fx over sigma f. The third step is to construct the column of x minus x bar. यानी हर क्लास के मिड पॉइंट में से आप वो अरिथमेटिक मीन सब्ट्रैक्ट कर दीजिए जो आपने अभी कंप्यूट की है. These deviations are the ones, some of which will be negative and some of which will be positive. और इन्हें हम स्मॉल d से डिनोट करते हैं. लेकिन जैसा थोड़ी देर पहले आपको मैंने बताया कि we need to take the absolute values of these deviations, so we can construct one more column, and that is the column of modulus of d. The last column that we will need to construct is the column of f into modulus of d. क्योंकि हर क्लास की जो फ्रीक्वेंसी है उसके साथ हम इस एब्सोल्यूट डिविएशन को मल्टीप्लाई करेंगे प्रायर टू समिंग देम in order to obtain sigma f modulus of d. Once we have this sum, of course, we should divide it by the total number of observations in order to obtain the mean deviation. ये तमाम स्टेप्स जो हैं मैं आपको इनकरेज करूंगी कि आप अपनी टेक्स्ट बुक की कोई एक्सरसाइज उठाइए और इन तमाम स्टेप्स को उसके ऊपर प्रैक्टिस कीजिए सो दैट यू फील एट होम विद दिस फॉर्मूला. आइए अब मीन डिविएशन की ग्राफिकल रिप्रेजेंटेशन पे गौर करते हैं. जैसा कि आपको याद होगा, मैंने पिछले लेक्चर में आपको कन्वे किया था कि रेंज जो है दैट इज अ हॉरिजॉन्टल लाइन सेगमेंट स्टार्टिंग फ्रॉम x नॉट एंड गोइंग अप टू xm, और क्वार्टाइल डिविएशन जो है दैट इज हाफ of the horizontal distance between the first quartile and the third quartile. मैंने आपसे ये भी कहा था कि मीन डिविएशन के केस में भी और स्टैंडर्ड डिविएशन के लिए भी, जो अभी हम थोड़ी देर के बाद डिस्कस करेंगे, because the basic concept is just as in the case of the range and the quartile deviation, that we are measuring the horizontal spread of our distribution. इसलिए इन दोनों केसेस में भी the measure of spread is depicted as a horizontal line segment. So, as you now see on the screen, the mean deviation is expressed as a horizontal line segment, and it is drawn below the x-axis starting from the middle of the distribution, that is starting from the point which represents the arithmetic mean. Students, mean deviation के बारे में हमने काफी तफसील के साथ बात कर ली. एक पॉइंट बहुत अहम है जो मैं आपको कन्वे करना चाहती हूँ. देखिए, ये जो एब्सोल्यूट वैल्यूज हमने ली हैं of the deviations, this step is not extremely defensible from the mathematical point of view. The argument is that we introduce a kind of artificiality in the calculation of the mean deviation by ignoring the algebraic signs of the deviations. यानी कहने का मकसद ये है कि असल में एक वैल्यू नेगेटिव थी और गोया हमने जबरदस्ती उसको पॉजिटिव बना दिया. सो फ्रॉम दिस पर्टिकुलर स्टैंड पॉइंट, the mean deviations formula is not an extremely preferable formula. हम इसके बाद जो measure discuss करेंगे, the standard deviation, students, in that you will notice that this problem has been overcome in such a way that our method is mathematically defensible and there is no problem. लेकिन पेशतर इसके कि हम उसकी बात करें, I still have to discuss with you the relative measure of dispersion corresponding to the mean deviation. और इसका बिल्कुल वही तरीका है जिस तरह का रेंज के केस में या क्वार्टाइल डिविएशन के केस में था. We will simply divide the mean deviation by the mean and obtain what is called the coefficient of mean deviation. The moment we divide the mean deviation by the mean, we obtain a pure number, and if I multiply this quantity by 100, my answer will be expressible in percentage form. Students, mean deviation के हवाले से एक और point भी मैं आपको convey कर दूं. Sometimes the mean deviation is computed by calculating the deviations not around the mean but around the median. So, as you now see on the screen, in this case, the formula for the mean deviation becomes sigma modulus of x minus x tilde divided by n. And in the case of grouped data, the formula will be very similar. The only difference is that we have an f coming after the sigma sign, and x represents not the individual data values but the midpoints of the various classes. और ऐसा किस सिचुएशन में होगा जब हम deviations मीन की बजाय मीडियन के अराउंड कंप्यूट करेंगे? साफ जाहिर है स्टूडेंट्स, ऐसा उसी केस में होना चाहिए ना when the median is the more appropriate average for our data set. और ये तो मैं आपको पहले ही कन्वे कर चुकी हूं कि in that situation when our data set contains a few very high or very low values compared with the bulk of the data, then it is the median which is a better average to use than the arithmetic mean. So, ऐसी situation में हम ये modified formula इस्तेमाल कर सकते हैं और इस केस में जो corresponding relative measure of dispersion होगा, that will be given by coefficient of mean deviation is equal to mean deviation divided by the median. All right, let us now begin the discussion of the standard deviation, the most important and the most widely used measure of dispersion. Students, ये जो मैंने आपसे अभी थोड़ी देर पहले कहा कि mean deviation में ये problem है कि absolute values जो हम लेते हैं, this step is not extremely defensible from the mathematical point of view. इसका जो हल हमने ढूंढा है वो ये है कि rather than taking the absolute values, we will square the deviations. And the moment you square the deviations, students, you will find that all your problems are over. If your deviation is a negative number, the square is going to be positive. If your deviation is itself positive, obviously, the square is going to be positive. तो इस तरह से हम वो जो नेगेटिव और पॉजिटिव के सम होने से हमें आंसर 0 मिलता था, उसको हम ओवरकम करते हैं इस सिचुएशन में by taking the squares. And when we do this, and after that adding all these squares and dividing by the number of observations, this particular quantity is called the variance. Formally speaking, the variance is defined as the sum of the squares of the deviations of the x values from the mean, and this sum divided by the number of observations. Symbolically, the variance is equal to sigma x minus x bar whole square over n. ये जो चीज़ हमने अभी अभी डिफाइन की, द वेरियंस, इसकी भी बहुत अहमियत है स्टेटिस्टिकल एनालिसिस में, एंड व्हेन यू गो ऑन टू further study in the subject, you will realize its significance all the more. फिलहाल मैं ये कहना चाहती हूँ कि स्टैंडर्ड डिविएशन कंप्यूट करने से पहले हम वेरिएंस की बात करते हैं, जैसा कि मैंने अभी की. And once we have defined the variance as the sum of the squares of the deviations of the observations from the mean and this sum divided by n, इसके बाद taking the positive square root of this quantity, we get what is called the standard deviation. So, as you now see on the screen, the standard deviation is given by the square root of sigma x minus x bar whole square over n. आइए उसी एग्जाम्पल पे वापस चलते हैं जिसका जिक्र थोड़ी देर पहले मीन डिविएशन के हवाले से मैं कर रही थी. As you will recall, the x values in that example were 4, 6, 2, 0, 3, 5 and 8. And this data pertained to the number of deaths in motorway accidents during one particular week. Now, as before, when we take the deviations x minus x bar, our values come out to be 0, plus 2, minus 2, minus 4, minus 1, plus 1 and plus 4. Now, this time we are not going to take the absolute values of these deviations. Rather, we would like to square each and every one of them, and doing so, the third column in our table comes out to be 0, 4, 4, 16, 1, 1 and 16. तो आपने देखा कि सारे squares obviously positive हैं, and now when I add these squares, the sum is 42, and dividing 42 by 7, my variance comes out to be 6. अब यहाँ पे एक और बहुत ही important point सामने आता है. Students, you will be interested to know that because of this process of squaring, the variance is expressed in square units. अभी जो example हमने consider किया, इसमें हम यूं कहेंगे that the variance is equal to 6 squared deaths. अब जाहिर है कि एक ऑर्डिनरी कॉन्वर्सेशन के पॉइंट ऑफ व्यू से इस बात का तो बिल्कुल कोई मतलब नहीं बनता. What do we mean by 6 squared deaths? लेकिन from the mathematical standpoint, this is exactly how it is. Because of the squaring of those deviations, the variance has to be expressed in square units. How do we overcome this problem? जो मैंने आपसे थोड़ी देर पहले कहा, that the standard deviation is defined as the positive square root of the variance. Students, this is the answer to this problem. The moment you take the square root, we are back to our original unit of measurement. So, in this example, when I take the square root of the variance, that is, the square root of 6, the answer is 2.45. यानी इस example में हम ये कह रहे हैं that the standard deviation of the number of deaths is 2.45. आइए ज़रा इस पॉइंट को तफसील के साथ समझने की कोशिश करते हैं। आपको याद होगा इस एग्जाम्पल में द एवरेज नंबर ऑफ डेथ्स पर डे वाज 4, यानी हम गोया ये कह रहे हैं कि अगर उन 7 दिनों में इफ एवरी सिंगल डे देयर वाज द सेम नंबर ऑफ डेथ्स फ्रॉम मोटरवे एक्सीडेंट्स, if it was the same number on every single day, that number would have been 4. लेकिन हम जानते हैं कि किसी दिन कम डेथ्स हुई, किसी दिन ज्यादा डेथ्स हुई। ये जो डिफरेंस है between the average number of deaths, that is 4, and the individual number of deaths for any particular day, हम स्टैंडर्ड डिविएशन की रूह से गोया हम ये कह रहे हैं कि वो जो डिफरेंस है ना ऑन द एवरेज, दैट इज इक्वल टू 2.45 डेथ्स। स्टूडेंट्स, दिस फॉर्मूला ऑफ द स्टैंडर्ड डिविएशन दैट आई हैव जस्ट डिस्कस्ड विद यू, इसमें थोड़ी सी दिक्कत आ सकती है आपको कंप्यूटेशन करते हुए इफ योर एक्स बार इज नॉट अ होल नंबर। अभी जो एग्जाम्पल था उसमें तो इट वॉज वेरी सिंपल and x bar was equal to 4. So we had no problem in computing the deviations of the individual x values from x bar. But if your x bar is a number like 2.3174, तो आप agree करेंगे कि इस situation में जो deviations हमें compute करनी होंगी, they will come out to be in decimals, और फिर जब उनको square करेंगे तो नंबर ऑफ डेसिमल्स काफी बढ़ जाएंगे एंड द कैलकुलेशन विल बिकम अ बिट cumbersome. So, in order to overcome this problem, I will present to you the shortcut formula of the standard deviation. And as you now see on the screen, according to the shortcut formula, the standard deviation is equal to the square root of sigma x square over n minus sigma x over n whole square. Students, बज़ाहिर ये फॉर्मूला पहले फॉर्मूले से भी ज्यादा लंबा और मुश्किल नजर आ रहा है, लेकिन आप यकीन कीजिए it is much easier to apply. The reason is that in order to apply this particular version of the formula, all you need is to construct a column of x square. यानी x column तो जाहिर है कि आपके पास पहले से ही मौजूद है, आपको सिर्फ x square का column बनाना है and you find the sum of the x column as well as the x square column, substitute them in your formula and you obtain your standard deviation. Applying this formula in our example, sigma x comes out to be 28 and sigma x square comes out to be 154. Substituting these values in the shortcut formula, our answer is 2.45, exactly the same as what we had earlier. Students, the formula that I just discussed with you, the original formula as well as the shortcut formula, these are valid in the case of raw data. What do we do in the case of grouped data? Exactly the same thing as what we have been doing all through. We will insert the f in the formula, and as you now see on the screen, the original formula becomes standard deviation is equal to the square root of sigma f into x minus x bar whole square divided by n, and the shortcut formula becomes the standard deviation is equal to the square root of sigma fx square over n minus sigma fx over n whole square. बिल्कुल पहले की तरह जब हमारे पास frequency distribution हो तो x जो है that represents the midpoints of the classes. Let us now apply this formula to an example. As you now see on the screen, suppose that we have data regarding the life of bulbs produced in a factory. Suppose that we have taken a sample of 100 bulbs and we put them to test in order to determine their life, and upon completion of the test, the life of these bulbs came out as you see in the first and second columns of the table. 4 bulbs were such which lasted between 0 and 500 hours. 9 bulbs were such whose life was somewhere between 5 and 1000 hours. 38 bulbs lasted between 10 and 2000 hours, and 33 between 20 and 4000 hours. Also, 16 bulbs were such whose life was either 4000 hours or more. जैसा कि आपने देखा, ये जो bulbs हैं इनकी life length काफी वेरी कर रही है. Suppose we want to measure this variation by way of the standard deviation. According to the shortcut formula that I conveyed to you, all we have to do is to first of all determine the midpoint of every class, that is x, and then to construct 2 more columns, a column of fx and a column of fx square. So, as you now see on the screen, the column of fx gives us the sum 2437.5, and the column of fx square gives us the sum equal to 78781.25. Substituting these values in the formula of the standard deviation comes out to be 13.900 hours. In other words, 1390 hours. So, I hope you understand, students, from all the discussion that we have done until now, that this figure of 1390 hours does not represent the mean life of these bulbs. अगर आप mean life compute करना चाहते हैं, फिर तो साफ जाहिर है कि आप sigma fx over sigma f की बात करेंगे, and as you can see on the screen, the mean life of these bulbs comes out to be 24.37500 hours. ये जो 1390 का figure है, that is not representing the mean life, rather it is representing the dispersion, the variation of the individual life lengths of those bulbs from the mean. स्टैंडर्ड डिविएशन को हम ग्राफिकली किस तरह रिप्रेजेंट करेंगे? बिल्कुल उसी तरह जिस तरह मैं आपके साथ पहले डिस्कस कर चुकी हूं फॉर द रेंज, द क्वार्टाइल डिविएशन एंड द मीन डिविएशन. सो as you now see on the screen, the standard deviation is also represented by a horizontal line segment which is drawn under the x-axis and which starts from the center of the distribution, that is, from that point which represents the arithmetic mean. Students, the standard deviation is an absolute measure of dispersion. जैसा कि आपने देखा, it is expressing the scatter of the distribution in exactly the same units as the units of the data itself. जैसा कि ट्रैफिक डेथ्स के एग्जाम्पल में हमने देखा कि स्टैंडर्ड डिविएशन वाज आल्सो एक्सप्रेस्ड एज सो मेनी डेथ्स, और अभी जो एग्जाम्पल हमने बल्ब्स की लाइफ लेंथ का किया उसमें आपने देखा कि 1390 के साथ हमने कहा कि द स्टैंडर्ड डिविएशन इज 1390 hours, exactly the same unit in which our original data has been represented. What is the relative measure of dispersion corresponding to the standard deviation? Students, as you now see on the screen, if I divide the standard deviation by the mean, I obtain what is called the coefficient of standard deviation. And if I multiply this quantity by 100, I obtain what is called the coefficient of variation, and it is a quantity which is of quite a lot of importance in statistical analysis. Students, चूंकि हम s over x bar को 100 से मल्टीप्लाई कर रहे हैं, इसलिए जाहिर है कि हमारा जो रिजल्ट है that will be in the form of a percentage. और जैसा कि मैं पहले कह चुकी हूं, जब आप परसेंटेज फॉर्म में एक्सप्रेस करेंगे अपने डिस्पर्जन को विच इज रिलेटिव टू द मीन, तो इसका फायदा ये होता है कि हम कंपेयर कर सकते हैं वेरिएबिलिटी ऑफ टू डिफरेंट डेटा सेट्स इवन इफ द यूनिट्स ऑफ मेजरमेंट ऑफ द टू डेटा सेट्स are very, very different. Let me explain this point to you with the help of an example. Suppose that in a particular year, the mean weekly earnings of skilled factory workers in one particular country were $19.50 with a standard deviation of $4, while for another country, suppose that the figures were 75 rupees and 28 rupees respectively. आपने देखा कि एक कंट्री में ये जो फिगर्स हैं they have been quoted in dollars, जबकि दूसरी कंट्री में the corresponding figures have been quoted in rupees. और दूसरी बात ये है कि ये जो फिगर्स मैंने आपको दिए उनसे एकदम से फौरी तौर पे वाजे नहीं हो पाता कि किस कंट्री में देयर इज ग्रेटर वेरिएशन इन द वीकली अर्निंग्स ऑफ द वर्कर्स. इन सच अ सिचुएशन द कोफिशिएंट ऑफ वेरिएशन comes to our rescue, and as you now see on the screen, for country number 1 the coefficient of variation is 4 over 19.5 into 100, and that is 20.5%, whereas for country number 2 the coefficient of variation is 28 over 75 into 100, and that is 37.3%. So, आपने देखा कि for country number 2 जहां पे अर्निंग्स रुपीज में कोट की जा रही थी, द वेरिएशन ऑफ द इंडिविजुअल अर्निंग्स फ्रॉम द मीन इज 37.3%, जबकि पहली कंट्री जिसमें अर्निंग्स डॉलर्स में कोट की जा रही थी, द वेरिएशन इन द अर्निंग्स relative to the mean is 20.5% only. And so it should be obvious that in the second country, this variability is approximately double of the variability in the first country. इसलिए कि repeating myself, पहली country में coefficient of variation is only 20.5%, लेकिन दूसरी country में it is 37.3%. Let us consider another example. Suppose that the crop yield from 21 acre plots of wheat land cultivated by ordinary methods averages 35 bushels with a standard deviation of 10 bushels. The yield from similar land treated with a new fertilizer averages 58 bushels, also with a standard deviation of 10 bushels. Students, अभी जो example आपने देखा, at first glance you might think that the variability is the same in the untreated land and the treated land. लेकिन अगर आप थोड़ा सा गौर करें तो आप नोट करेंगे that the variability in the yield from farm to farm has decreased in the treated land as compared with the untreated one. And how do I come to this conclusion? The easiest way is to compute the coefficient of variation. So, as you now see on the screen, the coefficient of variation for the untreated land is 10 over 35 into 100, which is 28.57%. But the same quantity for the treated land comes out to be 10 over 58 into 100, which is 17.24%. आइए इस मामले को थोड़ी सी और डेप्थ में समझने की कोशिश करते हैं. देखिए, अनट्रीटेड लैंड जो है उसमें एवरेज यील्ड 35 बुशेल्स है और जो स्टैंडर्ड डिविएशन है दैट इज 10 बुशेल्स. लेकिन जो ट्रीटेड लैंड है उसमें जो एवरेज यील्ड है दैट इज मच हायर दैन इन द केस ऑफ द अनट्रीटेड वन. इसलिए कि ट्रीटेड लैंड में एवरेज यील्ड जो है दैट इज 58 बुशेल्स. अब स्टूडेंट्स समझने की बात यह है कि 10 का जो फिगर है, वो जो वेरिएशन है ऑफ 10, उसकी जो सिग्निफिकेंस विद रेफरेंस टू 35 है वो उससे बहुत मुख्तलिफ है जो उसकी सिग्निफिकेंस विद रेफरेंस टू 58 बनती है. कहने का मकसद ये है कि 10 is a much smaller dispersion relative to 58 than what it is relative to 35. And this is exactly the point that is conveyed when we compute the coefficient of variation. All right. Today, students, we have covered quite a lot of ground. I discussed with you the concept of the mean deviation as well as the coefficient of mean deviation. And then we went on to talk about the variance and the standard deviation. The last thing I discussed with you was the relative measure of dispersion known as the coefficient of variation. I would like to encourage you to practice with these concepts by attempting quite a few numerical questions and also by studying these concepts not only in your textbook but in other books as well. My very best wishes to you, and until next time, Allah Hafiz. Assalamu alaikum. Welcome to lecture number 12